Awesome. All right. Welcome, everybody. And thank you for joining us for this special webinar series. Our guest today is Dr. Jeff Guan. We'll be discussing why AI is important to you. And for those of you all who are joining us from around the world, because we do have an international audience this morning, I wanted to take a quick moment and introduce you to the city if you're not familiar with it. So the University of Louisville is located in Louisville, Kentucky. We are a metropolitan area of about 1.5 million people, home to some major industry and business, a thriving economy, a lovely place to live. I say that it's kind of the best of both worlds in the United States. You're not on the coast, you're not too far north or too far south. It's really a city, but it's a small town at heart. So the thing that I enjoy most about Louisville is that you are really no more than 1 degree of separation from anyone in the city. So there's the chance that if you were to join us here at the University of Louisville to earn your graduate degree, you would have amazing opportunities to network and connect. It's a wonderful place to live and be. And then really quickly, the University of Louisville itself. So we're coming up on our 225th birthday. I know we don't all look that old, and most of us aren't, but the university is. So we're very proud of that. We've been kind of a staple here in the United States for quite some time, one of the oldest universities here. We are an R1 research institution, meaning that our faculty engages in one of the highest levels of research here in the United States that they can. We have over, approximately now about 24,000 total students. Of those 24,000, about 18,000 are going to be undergraduate students. About 6,000 or so will be graduate students. And in the College of Business, we have approximately 550 students in our graduate programs from all over the world. So we're really a very tight-knit community, but we're a global community, and that's something we pride ourselves on. We will be talking today with our special guest, Interim Dean, a former MSBA program director, a professor of information systems, analytics, operations, and probably a few more things that I didn't have room on my slide to put on here. But Dr. Jeff Guan has taken time to join us today to talk to us about the importance of AI in our lives and our future. And so with that said, Dr. Guan, I'm going to go ahead and turn it over to you, and the floor is yours, my friend.
Well, Stephen, thank you so much. Thank you, and welcome everybody to this session. And I can see that we have a few guests. And again, my name is Jeff Guan, and I was named the interim dean when my predecessor left in the summer. So I became the interim dean on August 1st. Before that, I was the associate dean for programs, and also the director, like Stephen said, of the Master of Science in Business Analytics program. And today I'm honored to have this opportunity to speak to you about AI. I thought about it this week, and I decided not to use any slides. So I want to treat this as pretty much a conversation. And so I'll talk to you about AI and why I think AI is important. So I want to start with an event that occurred in 2016. And so it's fairly recent. So in the year before that, 2015, there was an article in New York Times by a theoretical physicist. He's very famous, and he made the prediction that it would take another 50 years for us to come up with a computer program that can beat humans in the game of Go. Now, most of you may not be familiar with the game of Go. It's an Asian game, and it's ancient as well. And it's a 19 by 19 board, and there are only two types of pieces, black and white. And the idea is to win by having most of your pieces on the board. And now, for every move, there are 250 possible moves. And so think about that. So the number of possible moves is tremendous. So for a lower bound, in other words, the least possible number of moves, it's about 10 to the 180th. Now it's 10 raised to the power of 180. So that's a fairly large number. How large? Let's say the number of atoms in the known universe is X. And then the 10 to the 180th is larger than X squared. So think about that. And so it's a strategy game. But interestingly, there's a Google subsidiary called the DeepMind that's based in London. It's run by this genius called Demis Hassabis. And his team came up with a program in 2016, and it's an AI program, and it's called AlphaGo. And AlphaGo, it's called ALPHA Go, AlphaGo. So AlphaGo was able to beat the best human player, Lisa Do at the time, he's a South Korean, 3-0. Now that's a definitive win. And that was in 2016. And in 2017, DeepMind came up with another version of AlphaGo. And this newer version beat the old version 100-0. And so now, but what's amazing about this second version of the program is that it actually learned to play the game by itself. So it wasn't taught the rules of the game. It just simply learned to by watching. So that's what's amazing. And that was the state of AI in 2017, 16. And today, another 5 years later, it's actually moved beyond that. Now, and I'll talk about that. Now, why is this important? And this is important because last time something of this magnitude and scope happened, a lot of changes occurred. And I would like to review those two historical periods so that I'm looking at the audience, you all look very young to me. And probably the next 25 years of your life are going to be the most important and productive of your life. So it is very important to understand what's happening or what's going to happen or likely to happen in the next 25 years. So first of all, around the turn of the last century, about around 1900, we switched from steam engine to electric motors. And steam engine, of course, started the Industrial Revolution. So it was really huge, right? But one of the limitations of steam power is that you had to have your machines close to the source of the power. So that was a huge limitation, as you can see. So around the turn of the century, 1900, we came up with electric motors, but the people's attention was focused on how much fuel the electric motors would save them. Indeed, it would save them like 20-30% in fuel cost. And that's significant, right? Because at the time it was mostly manufacturing. the industrial wealth was mostly centered on manufacturing. And as a result, most of the companies were focusing on fuel cost savings. And but they ignored some of the biggest benefits of electric motors. In other words, power decentralization. It's because with electric power, all of a sudden, the machines didn't have to be close to the power source, and you can reconfigure the machines, and all of a sudden, you can produce close to where your products are going to be sold, say, for example. So it would save on your transportation cost. It would save on, your logistic planning, and so on and so forth. But so most US companies, I'm talking about the US, didn't realize that. So by 1930s or so, many of these top tier companies, about 60%, they fell from their top spots. So this is clearly an important lesson. And I want to keep that in mind. Today, we take power decentralization for granted. Say, for example, I'm in my office, and in some parts of the building, there are offices without windows. But we can still use those offices during the day because we have electricity, right? So the decentralization of power, the ability to transport power over long distances, that really changed the rules of the game, right? So that all of a sudden, we can build buildings that can better utilize the interior space, that can use the basement. Or say, for example, if you live in the US, you probably live in a house with a basement. And so all of those things, all those innovations were made possible by these new technology that we now today take for granted. But at the time, it was very new, electric motor. So think about that. Think about the impact that this technology had on us, right? And maybe our grandfather and our father's generation, and for you, your great-grandfather's generation. So this is one example. So let's go further to more recent historical period. I remember in the 1990 or so, I was still in graduate school, and we started hearing things about these called the internet. In fact, I was taking classes. It was a class called computer vision. I'm a computer engineer by training. And we were taking computer vision classes, doing image processing. And our job was to create a neural network program to recognize ships, in fact, battleships, as either friend or foe. In other words, my professor got a grant from the Defense Department so that he would have, he received a lot of images of ships. At the time, it was Soviet ships and NATO ships, because NATO ships are friend, and Soviet ships at the time, still is today, a foe. So we were writing computer programs, but we were able to get on the so-called internet, and the World Wide Web was created. And again, it's a decentralization of information, right? So the information is no longer centralized. In other words, you don't have to go to the library anymore in order to access some information. It's all decentralized. It's easy to access. So this is called the internet revolution. So this, of course, is something that you can actually relate to as you grew up with it. And but I don't know if you have thought about the change that it has brought in terms of the things that you have experienced at work, at school, and in your social life. And say, for example, Uber. Now, most of you probably have taken Uber. If you're not in the US, you probably have taken something similar to Uber, right? And so Uber, of course, is in the US, it's the largest taxi operator without owning a single vehicle. Think about that, right? It's the largest taxi operator. And then there's another company like that, and it's called Airbnb. Airbnb actually is the largest hotel operator without owning any real estate. Now, think about that. And this is a so-called platform economy. And this has generated an entirely new class of businesses, right? Because the internet, the World Wide Web, has allowed the consumer and the provider of services, in this case, Uber and Airbnb, to reduce the amount of friction between the transaction. So when you say, for example, call for Uber, and you get into the car, and you arrive at the destination, and then you leave, and you say thank you to the driver, and that's it, right? And then you step into, say, for example, if you're going to some place, you step into the departure lounge at the airport, and then you get your ticket, plane ticket, boarding pass, and then you decide how much tip to give to the driver. So the transaction is completely free of friction in this case. And so this is the impact of technology on the economy. And so I want you to start thinking about that. In fact, the internet has a much larger impact. So let me give you another example, something that you can relate to. And you are probably all are either an undergraduate student or have finished your undergraduate degree. And while you are studying in school, you probably encountered a situation where you didn't have your textbook until the very first day of class, and then you needed the textbook. And you can go, of course, to Amazon or some textbook provider online and get a copy of the book. And the copy of the book you get can be sent to you instantly. So this is what I'm talking about. It's an economy. So we have a huge economy here in the US and in the world that I could characterize as instant, free, and there's a third characteristic. So let me think. So it's instant, free, and perfect. So it's perfect because every copy Amazon of the textbook that Amazon sells is going to be in as good a quality as the next copy it sells because it's a digital product, right? And similarly, every song that Apple sells is going to be as perfect as the next copy. Now, it's free because the marginal cost of the textbook to Amazon or the marginal cost of a song of Apple is practically free after they have sold a certain number of copies. Now think about that. That's a very powerful idea, right? So the marginal cost, if you have taken the economics class, you would understand that concept. And so that is why we call it free. And of course, it's instant because once you have hit submit, the textbook is downloaded onto your laptop or your cell phone and so on and so forth. I don't have time to read books, but I drive a lot. So I listen to books and I buy books. Well, once I buy a book and I hit buy, and of course the book is downloaded onto my phone instantly. It takes about literally seconds to have the book downloaded. So this is, again, an example of the impact of a technology, in this case, the internet, on everything else in our society, right? Our work, our life, and anything in between. So I want you to start thinking about that because now we're stepping into another such period, the period in which a technology is going to have a huge influence on us, such as AI, right? So why is AI so important? Why is AI going to make an impact on our species as the other two technologies, such as the electric motor and the internet, have on our lives. And let me give you an example, right? So I'm in the business school. I'm the interim dean of the business school. So I work with businesses a lot. And in Louisville, because I'm not supposed to reveal the name of the company, but if there's a very large insurance company, health insurance company. And this was a few years ago when I was still just a professor. And as a professor, I did consulting projects. I created databases. I do other things for local businesses and sometimes for national businesses. And in this particular case, this insurance company had a problem. In other words, it had an overpayment problem. Overpayment is a situation when a patient got sick. Let's say, for example, a patient got injured in a motor car accident, and or some such incident, and so the health insurance, of course, would be used to pay for the care, right? To help the patient recover and so on and so forth. But really, the motor insurance company is responsible for the costs. So that's one example. And sometimes a doctor's office will overcharge. And sometimes there's actually fraud. So there are many situations where an insurance company, health insurance company, overpays. In fact, the amount of overpay is about $300 million. And that's a lot of money. So they obviously wanted to reduce the amount of overpay. And so what they wanted to do was to hire 200-300 people. It's an entire floor of a large building. I was there. I look at those people because each insurance claim record contains about 300 plus fields. And these are variables, right? These are variables, and these variables actually can be used to predict if the particular insurance claim is a fraud case or is an overpayment case. And now humans, of course, it takes a long time for a human employee to become an expert in recognizing whether or not the case is a overpayment case, so that they can pursue that, because they have millions upon millions of cases, right? They can't just pursue every case. They have to identify the likely cases and then spend time and energy and resources on those cases. So we participated in the process to find an AI-based solution to identify overpayment cases. In fact, that is the case today. Today, we don't have 200 or 300 people there working to identify likely overpayment cases. It's an AI it's an AI process. So that's just one simple example. And let me give you another example, this time of a much greater significance. Remember the DeepMind company and the AlphaGo program? So that program was the basis to for another program. It's called AlphaFold, F-O-L-D. Now, why is it fold? Because it has to do with protein structure identification. Now, a protein is the most basic building block of life, right? And certainly of our species. So a typical human has about 80,000 to 240,000, I can't remember the number, proteins. And it would take a highly trained individual, such as a doctoral student in life sciences and biology, to identify the structure of a protein. A protein is actually a three-dimensional structure of a sequence of amino acids. And so, if it's a linear sequence, you turn that into a 3D structure. There are many possible 3D structures, right? But if a protein is not structured correctly, you get sick. You get cancer, for example, and all kinds of other strange illnesses. So therefore, for us to be able to properly identify the protein structures is critical. But it was a very time-consuming process. Sometimes a difficult protein structure can take a team of scientists, life science scientists, 10 years to identify. Now, AlphaGo was the basis of a program called AlphaFold, which were released in 2018 and 2019 in that time period, that was able to accurately predict the structure of a protein given a sequence of amino acids. And it did such a great job that the magazine Nature called it in 2020 a game changer. Indeed, it actually put a lot of data a lot of scientists out of their job. In fact, no, that's not what I meant to say. Actually, these scientists now they can focus on more important tasks so that the identification of a protein structure can be much faster. Now think about that. You're all going to get old, and you're all going to get, hopefully not sick, but if you get sick, or if you say, for example, Alzheimer's, right? That's a problem where advances like this could really help. So AI now is everywhere. In fact, our university was looking at several vendors that provide an AI tool for advising students. So it is now very common for a university in the US to use AI to advise students, because an AI can not only answer generic questions, but they can also answer questions about a particular student, because the AI can go into the database, grab the current classes that the student has already taken, and then based on the program that the student is in, and make a recommendation on what classes to take. And some classes are closed, some classes are still open, and AI can do all of that today. Isn't that amazing? And so this is the kind of changes that are occurring. And if you're not aware of these changes that are occurring, it's gonna affect you, right? So now let me just Stephen, probably my time is, how much time do I have? I'm still good.
Oh, you're good. We're
You're
good.
good.
Okay,
Yeah.
all right. Let me take a sip of my coffee.
Yeah, no, you're good. We'll leave 10 or so minutes
Okay.
at the end
All right.
for
So that's what I'm. So let me go back. So what is AI, right? So now you're going to ask the question, what is AI? So AI is actually when I was choosing my graduate school, I was trying to decide what to do, right? What field to get into, because I like computer science. I decided to get a master in computer science, and as I was studying computer science, I took classes like computer vision, as I was telling you, and then I found it was truly amazing that we can write a program not only to recognize images, but also to recognize voice. So today, if you're in Louisville, you go to a grocery store such as Kroger, and you can actually interact with a machine at checkout, right? In fact, most people check out with using a machine than a human cashier. And in fact, that technology was developed in the late 80s of the last century. And so we wrote programs so I was fascinated by that. And so I started playing with that. And so I decided to major, when I did my PhD, I decided to focus on AI. So my PhD work was on the creation of an AI program to monitor alarm systems in the large manufacturing facilities, such as a nuclear plant. Because when a nuclear plant, security is critical. If anything goes wrong, the alarms goes off. You want to be able to quickly identify the source of the problem. And that was what my program or algorithm was designed to do. And so AI is actually, today, of course, it's no longer non-traditional, but at the time, it's a non-traditional way of prediction, right? That's just one of the major things AI does. Say, for example, if you want to drive to the airport, right? You want to take, when you want to miss your flight, but you don't want to go to the airport, so you spend a lot of time sitting at the airport waiting for your flight, because everything there is so much more expensive. So therefore, you use a tool such as Waze or something like that, or Google Maps, and it can give you a prediction based on the traffic, how much time you need to travel. And that's AI, right? And so AI, a lot of it is based on statistics. So if you want to know AI, you need to know statistics. So that's why in the MSBA program, we have 9 hours of statistics, because you truly need to understand statistics. Let me give you another example why statistics is important. So there's a very famous AI algorithm. It's called decision tree. Decision tree is a great tool, very effective tool for prediction and classification. But the ability of the decision tree to do that is based on its ability to put distinct objects into their own categories, right? So if you say, for example, you have 2 groups of people, one have symptoms, one likely to have COVID, one likely not to have COVID, right? And they have symptoms, and you can use a decision tree to put them into 2 different groups. And decision tree is good at doing that because it uses a very, very basic statistical concept called chi-square statistic. And so if you can look it up, it's very basic. The idea is very basic, but you probably have to read a few chapters of statistics to understand chi-square statistic. So the point I'm trying to make is that an advanced AI algorithm such as decision tree is actually based on a lot of basic statistical concepts. And so, in fact, most of the things that you use at daily work, they're very basic, they're very fundamental, and that's what we focus on in this program. And we had, let's see, when I was teaching in 2018, we had our first cohort, and there were 2 girls in there. One is, she has an accounting background, and one has a math background. In other words, the undergraduate, one has accounting undergraduate, and one has a math undergraduate. And they were both in my classes. And they both took my class, machine learning, where I taught decision trees, neural networks, and support vector machines. I mean, there are these fancy AI algorithms, and I show them how to use these algorithms to solve business problems. And now they are at one of the largest healthcare organizations in Louisville, and they are leading the AI deployment effort. In other words, because that large organization, healthcare organization, actually has about 17,000 employees, including nurses, doctors, and so on and so forth. And they say that to be able to provide the most competitive, but also the highest quality healthcare, they need to adopt AI. And they hired both of these girls to lead the effort. Isn't that amazing? Right? So they're actually transforming, they participate in the transformation of their industry. And opportunities like that are so plentiful, at least in the US. And many organizations, they realize that the change of this magnitude and scope is going to affect them. And they know that they have to change. But sometimes I talk to businesses that they're frustrated because they don't have anyone in their organization that understand AI. So therefore, they don't even know where to begin to make the change. You see, that's the problem a lot of the businesses face. And in a large organization, you may have an excellent department where you have data scientists, AI specialists, and so on and so forth. But every division, they may have 3,000 people, right? They have their own problems. They can't go to the larger central organization for help every time they need something done in AI. So they need to hire their own AI people. In fact, what I have found is that businesses like to hire employees that truly understand AI, someone that has been through our program, for example. You can also go to MIT and do the AI program, but our program is as good. And so you not only have to understand AI, but you also, they prefer someone that has some business background. So that's why that accounting girl, she was highly valued by the company. And in fact, a Fortune 50 company's CTO, Chief Technology Officer, told me, he said he wants to hire technologists, people into IT that can frame the problems. In other words, they can ask the right questions and put the answer to the question in the context of the business they operate in. All right. I think I can keep talking for many, many hours, but I know for some of you it's evening and here it's the morning. I'll stop at this point because I know Stephen and Ning, my colleagues, have wonderful things to share with you. But thank you. I don't know if I am supposed to take questions or anything like that, but I'm at your disposal.
Yeah, so we've got time for questions. We've got one in the chat, and one came to mind for me. So I just anecdotally yesterday I was meeting with a gentleman who's an IT infrastructure engineer for Amazon, and he's been with them for 10 years or so. And we were talking about AI, and I asked him, how it's impacted, his work. And he said that, about 6 years ago, he developed a program to help him deal with basically help queries, right? So they're changing their software, they're updating, they're migrating things to the cloud. So much like when you're developing alarm systems for nuclear power plants, he was thinking, alarm systems for their infrastructure. And he said that it used to be 5 or so years ago that a staff of 6 to 10 people would work 5 to 6 hours a day monitoring these things and making sure everything worked. And that he developed a system that in the beginning cut that time and the amount of resources he had to commit to these tasks in half. And I said, well, that's great. What does it look like now? And he said it went from, I think he said it was 6 to 8 hours a week of the machine monitoring and helping solve issues to now 4 minutes a day that the machine can facilitate some of these fixes. And he said the problem was in the beginning that we didn't know what we didn't know, and that there wasn't enough data coming in. So as we move to this kind of AI centric world, what role do you see in humans in providing or measuring or scraping data to help make the AI as efficient as possible?
Stephen, was that a question for me?
That was for you, man. I can't answer that.
Okay. All right. That's great. That's a great question. I get that question every day. So yes. So first of all, technology is advancing, and technology will keep advancing. And in the early days of computing, so let me take some time to answer the question because this is a really important question. In the earlier days of computing, you had to write code for everything. Now, let me give you an example. I was writing image processing program and using neural network. And in other words, an image is actually turned into it's a matrix, right? It's represented as a grayscale representation of the object. And so to do that, you have to perform a transform called Fourier transform. And Fourier transform is a very time-consuming process. And someone came up with a very clever way of doing the transform called fast Fourier transform. So it was, of course, a set of mathematical formulas. But in order to automate that process, because I can't process an image using hand calculations, right? So I wrote a program to do that. It took me a month, right? And of course, I slept and played basketball and did some other things, but I almost did nothing else during that month writing that program. I had to test it, and then it worked. Now, today, technology has advanced today so that I could do that in a few seconds, because all I have to do is call this method or this function if you have programming experience. So it's there, right? But the problems have also become more complicated. And like Stephen was talking about, describing just now, the data, right, that we're able to process also have become more accessible, but they are more complicated as well. So you pretty much are going to be a problem solver. And to solve the problem, first of all, you have to know what the problem is, right? So you have to understand the business. Once you understand the business, you have to know what kind of data that you need to collect to solve that problem. And so here, your business knowledge, both your business knowledge and your technical knowledge come into play. So you need to say, the example I was given earlier of variables, right? In that insurance claim example, there are 300 plus variables. So which variables could you pick? Which are the variables that are good predictors? Say, for example, the color of the hair of the provider, the doctor's hair color probably is not a good predictor, unless if some doctors like to color their hair green, right? The green color, does that predict overpayment? It may not, right? But you don't know. So you need to deploy methods today to select the variables that are the best predictors. Now, to do that, do you have to write code today? You don't have to write code, but you have to choose the method, right, that's most effective. There are tons and tons of methods out there. And then when the method produces a result, you have to be able to interpret the results. Now, how do you know if, the method comes back with a set of results and it gives you a bunch of statistical metrics? You need to be able to interpret those statistical metrics, right? Even though it's an AI method. So variable selection is just an example. You can't use 300 plus variables because it's probably not going to do any good, right? So you have to narrow it down probably to about 4 or 5 or 6 or 7, or even just 10, right? That's quite a huge reduction. So and then you have to pick the algorithm. And then, of course, picking the algorithm again brings a lot of AI knowledge to the process. Again, you're not writing the algorithm like I did. I had to write my own algorithm, right? Now you have to pick the algorithm. And this is what our classes teach, right? We teach you the logic of the algorithm. We teach you why it works, what result it produces, and how to interpret those results. Okay, so anyway, so that's this reality you're going to be walking into in a year or two if you are going to do our program or another program, let's say. I think MIT has a better program. All right, I have to admit that. But ours is pretty much as good as all the others. So if you go into a job And that's probably what you're going to be facing, right? And so let me give you another example to answer that question. I was with a company which is a aggregator. An aggregator meaning that they buy medical supplies for all the small doctor practices. Because if you're a doctor's office, you have 5 people. It's very costly for you to buy medical supplies yourself, because then the cost will be fairly high. But if, say, for example, you aggregate the orders for, say, for example, some kind of a medical gloves, and you aggregate them, if you buy in bulk, then all of a sudden it's much cheaper, right? So this company does that. It's one of the largest in the nation, actually, but it's based in Louisville. And they want to be able to identify the top 20% of their customers. So because they want to treat them well, right? And because of the very complicated acquisition process they have, they couldn't do that. And it bothers them really. It really bothers them. So they talked to me, hoping to get my help. But I said, I don't have time, but this is not a difficult problem. One of our graduates can do that. Anyway, I connected them with a program, and I don't know what happens afterwards. They haven't come back to me. I guess that they probably someone found a solution. So this is what you're going to be walking into. Your knowledge of statistics, programming, because you always need to customize sometimes, right? So your data doesn't come in perfect. So for example, you have to combine 2 columns of data into 1 column, but it's not a simple combination or concatenation. You have to pick certain attributes from the first column, change them somewhat, and combine them with the content of the second column. And that requires some type of programming. Sometimes it's in Python. Sometimes if it's in SQL or R. So that's why we teach those classes. But fundamentally, you're a problem solver. All right, Stephen.
Yeah. So we have another question, and after that, then we'll give a brief introduction. I'll give a brief introduction to our business analytics program, which I think is a really good building block for people who are interested in this sphere. So the question is, well, I guess there's 2 questions here. One, do you think that technology will advance past AI? Which is, maybe a scary thing to think about. And secondly, what advice do you give to people that are new in this field?
Yes. So it's very hard for people to make predictions, especially in terms of where technology is going to, where a particular technology is going to be. But whatever happens with AI and other technologies, I would dare to say that knowing AI is going to put you in a much, much better position 20 years from today than if you don't know AI. So no matter what you do, right? You're in insurance, you're in manufacturing, you're working at NASA for the government, knowing AI is going to set you apart. It's not going to be easy. It's a lot of work. And let me give you an example. Julie, I'm not going to give her last name. She was a communications major, and she joined the program in 2019 when I was still teaching. And she struggled mightily in my database class, because I teach database and machine learning. Those are the 2 classes I teach. But she persisted, and she suffered through the class. And so she was enrolled in August, right? She started the class in August. By October or so, after the database class, she got hired as a database intern at one of the local healthcare companies. She became a database programmer. And then by March of next year, so before she graduated, she was offered a full-time job. And so yes, so I'm answering the second part of the question. If you're new, even if you are in the field that's totally unrelated. And in her case, she had these communications undergraduate degree. She was in marketing for about 10 years. She had worked for 10 years. She saw no future for herself. She's very smart. She said, okay, I have to switch career. I have to move into something that is going to be with us, a skill set that will be desirable for the next 25, 50 years, right? And that's what she does. And God knows she's such a great communicator, and because she really can bring a point across. And I think she has a great future. And now that she has technical skills. So if you're new to the field, I think get the fundamentals, okay? We have, Stephen will talk about programming is fundamental. You don't have to have programmed before because the basic tricks of programming are very simple. Most of the things you learn, you're going to learn at work, at your job. So we're going to get you to a point where you are attractive to a business. That's our job, right? And then, of course, after that, your first job, you gain practical experience. In fact, while you're in the program, you're going to gain experience. And you're going to, of course, be more and more valuable to yourself and to of course, to other businesses. And actually, it's when you don't know, like Stephen used the phrase, you don't know what you don't know. And indeed, it's difficult for you to imagine what it would be like to know programming, what it would be like to really understand statistics and machine learning, AI, storytelling, and so on and so forth. But the program is going to be transformative in a very good way.
Yeah. So it's one of the things I appreciate most, Dr. Guan, when speaking with students is it doesn't matter what background they have or what industry they're interested in, where their passions are flowing. You know, the business analytics program that we offer people is really it's a Swiss Army knife. It's a universal tool that can be applied to almost any industry. Yesterday, I had the pleasure of meeting with the founder of a company called Tagnify, and Tagnify is focuses in providing data to companies that are in mergers and acquisitions. So large companies, both public and private, trying to acquire smaller companies or emerging companies at a deal, right? But in order to do that, they need the companies that are doing the acquiring want to know as much as they can about the market or even the company that they're buying. And they were telling us for the public companies, when a company is bought, a lot of that information is public knowledge. But at first they had to build a tool that is going to process the information because it was being shipped to them in paper stacks, the financial records. So they had to build a tool that was going to read it and then put it in an Excel sheet. What's more difficult, he said, was there's tons and tons of private acquisitions that happen every year where the data is not readily available. So they built a web trolling machine that goes through and is gathering data and putting it in digestible format for their clients. So when you go to buy a company to add to your portfolio, you'll have access to information and know what's happening in the market. And that's not something that could have been done even 5 years ago. So it's really exciting to see that in the mergers and acquisition side of things. And of course, we've mentioned automotive, industrial, computers, we've mentioned marketing, we've mentioned healthcare. This program that we're going to talk about here in a second really is applicable to almost everyone. So with that, Dr. Guan, if you need to run, I know we're on your hour here. Feel free to take off, and thank you so much for your time. We really do appreciate you joining us for the hour here this morning.
Thank you.
Yeah.
I do have to go to my next meeting, but thank you very much.
The burden is heavy. All right, thank you. Take care. So real briefly, for those of you all who want to stick around, I want to talk to you about our graduate program in business analytics. my colleague here, Ning, is joining me as well. She is one of our recruiting managers for this program and our other graduate programs. But I wanted to do a quick run through, not to take too much more of your time, of what our program is, why some people are doing it, and some of the outcomes. So if you'll just bear with me for 5-10 minutes. And then at the end, if you have questions about the program specifically or the application process, feel free, of course, to put those in the chat. I am going to cycle through these slides in the interest of time for you, but we have two programs that are STEM designated that focus on analytics. One is an accounting and analytics program that is approximately 50% accounting curriculum, 50% analytics tools, so data visualization. We know, and our students and our prospective students and our business partners tell us that in the accounting field, increasingly big data analytics is more important, but also the automation of such of those analytics is increasing every day. There's a new company probably born every day that's getting into this field. And over the next, I don't know, I think it was 5 years, there are more people leaving accounting than there will be people going into it. So we recognize that those going into the field are going to have to be more efficient and have to be better skilled. But because of supply and demand, they're also going to drive high wages and high salaries, which is going to be great for our students. And then the one that we'll spend most of our time on is the Master's of Science in Business Analytics. Dr. Guan is, I just noticed a typo on here. Dr. Guan is was the program director for this. He really built this in conjunction with our business partners. So in 2018, he went out into the community and said, hey, we're a business school. We're preparing our graduate students to be leaders in the future. What is it that you're missing in your talent pipelines? And they all came back and basically said, the future is big data. The future is analytics, but really more importantly is the articulation of data. Some of us don't have the time, knowledge, to commit to understanding massive spreadsheets, depending on what industry you're in. So what this program is going to allow our students to do is articulate big data in a way that's consumable to the decision makers, or make you a decision maker because you are the interpreter of the data, right? So on this screen, you're going to see kind of a wide variety of tools that we're going to prepare you to be able to use in the real world, from Tableau and Power BI, and Python and R, and a little and SQL as well. So what does the program look like? This is actually evolving as we speak. So for example, you'll see we have our core areas here. That changes every year depending on technology, depending on what's happening in the field, because our whole goal is to prepare you to be a data scientist or data analyst. So as that field is quickly evolving, we're still kind of in the steam engine era of big data, but it won't take us long till we're all driving Ferraris in big data. Probably, just when we think we're going at light speed, it will be exponentially amplified. But we're moving Power BI from our elective side of things into our core curriculum next year. And the reason is it's a really common tool that most industries can take advantage of, a data visualization software. So think Excel, pivot tables on steroids, and there's some automation that's you're able to do in that as well. But more importantly is what we do is we integrate industry experts in our program. So yes, most of your faculty, especially in the core classes, are going to be tenured faculty who've studied this, written papers, literally written the book on some of the courses you'll be taking. However, when it comes time for like the electives and some of the non-core classes, we invite leading industry experts to help us teach that. So on this page, you'll see some some great names. So Mia Sims is someone that Dr. Guan was talking about earlier, a math major who at one point was working in the Churchill Downs gift shop, managing the gift shop, not exactly the best use of her potential. She did the MSBA. Now she's working on AI automation for Ford Motor Company. She teaches our AI and analytics elective course. A gentleman from Meta, Facebook, teaches AI and ethics for us. You'll see senior data scientists from Yum Brands, from Humana, from Apris, from LG&E and El Toro, all represented in our program. So you're learning from the people who are doing it on the cutting edge right now as we speak. There's really no substitute for that kind of value. And then one of the unique things that we offer in our program, it's not for everybody. This is optional, but we did have someone mention, hey, I'm new to the field. I'm getting into it. What should I do? Well, one of our competitive advantages is that we do offer competitive base paid internships in our program. The way that works, students who are admitted during your application, you'll check that you're internship seeking. If you're admitted and you pay your deposit, what we do is we take your resume, we ask you to put it in a standardized format, and then we start matching you with our business partners for potential job opportunities while you're in the program. You have to interview. You have to have some marketable asset that we can put in front of them. It could be your personality, it could be your willingness to learn, it could be your GPA, it could be that you have some experience in a related sector. Maybe you're in finance and banking, maybe you've done marketing or sales, but you want to focus more on the analytics side of things. We match you with them, they hire you, they like you, you start working 20 to 30 hours a week. Our MSBA students earn closer to $28 an hour on average, depending on the company, depending on the role, which allows our students to earn approximately $25,000 during the course of the program. But better yet is that most of those students are going to be offered full-time jobs before they even graduate. And they're able to do that because they have skills that not everyone has. Again, supply and demand, right? The supply is low, demand is high for the skills that you all will be learning in our business analytics program. Just a couple of companies that we do partner with. We have over 300 business partners over the past year and a half who have taken on our internship, our interns, our students as interns. In 2021, last fall, was our biggest internship class, partially because we were all still coming out of the pandemic, but we were able to place 175 graduate students in paid internships. This year, we don't have as many students looking for internships. The market's a little hotter. For our program that started 2 months ago, we're over 80% placement or match, that is, and we're hoping to be at 100% by the start of the new year. So again, the demand is high for these students and for the skills that you're going to learn in these programs. We do have January and fall start dates for our analytics programs. If you are interested, please feel free to reach out to myself or to Ning, and you can find our contact information here. But the process is pretty straightforward and you can be found on our website. So with that, I'm going to come to a conclusion here unless we have any other questions in the chat or on the microphone here. And I'll put my email in the chat here as well, and Ning will too. All right. All right, any questions for myself or for Ning? And there's Ning's email in the chat. Again, feel free to reach out to us anytime. We really do appreciate your time this evening, this afternoon, this morning, wherever you may be located. We look forward to the possibility of you joining us here in Louisville, Kentucky. One of the best cities in America, as far as I'm concerned. If you don't know much about it, look it up. But don't tell too many friends because we enjoy kind of being the best kept secret here in the States. Ning, thank you so much for making this happen. Thank you all for attending. Have a wonderful evening, and I hope to see you all in August of 2023 or perhaps in 2024. Take care.
If you have any questions, email us.
Absolutely.
Take care.
Bye.